In this video I'm going to demonstrate the use of the quotient rule to find the derivative, and in this function we have exponentials and we have natural logarithms amongst other things. So we can clearly see that there's a function of x in the numerator and a different function of x in the denominator. So a good candidate for the chain rule will rewrite this as u over v, where we define u as the natural log of x. Immediately I will find the derivative, du dx. Derivative of ln x is 1 over x. That's one of our standard rules. V is e to the x plus 1. And again, I'll find the derivative dv dx immediately. Derivative of e to the x is e to the x plus 0, because derivative of 1 is 0, so that's nice and easy. We've done all our preliminary steps. We've defined what the numerator and the denominator functions are. We found the derivative of each. So now we need our quotient rule. dy dx v times du dx minus u times dv dx all over v squared. Now, don't try to cram all of this into the space between two lines here. It's way too way too compact, and spread it out a bit. Use a bit of extra paper. Make the setting out easy to follow. V was e to the x plus 1. Times du dx. Du dx is 1 over x times 1 over x. Minus u is the natural logarithm of x times dv dx was e to the x, all divided by v squared. V is e to the x plus 1 squared. So we have some simplifying to do. Now this term e to the x plus 1 squared, I might just move that for a moment. E to the x plus 1 squared. Extract that as a factor so that I can just work on these. And remember, that is multiplied by everything, so everything else will end up between some brackets, so that this applies to the whole lot. This first term is e to the x plus 1 over x minus e to the x times the natural log of x. Really, that's the same as over 1. So I'm going to try and combine these now. 1 over e to the x plus 1 squared. Now, in order to combine these, I need a common denominator. So I'll make a common denominator of x. That hasn't changed, so we have e to the x plus 1 minus. Now I'd need to multiply that. Effectively, I've gone multiplied by x here and multiplied by x. In my mind, I've thought this. So I end up on the top with x times e to the x times the natural log of x. 3 parts. And this is all multiplied by this, so we could, there's no like terms here, so we'll just leave this as e to the x plus 1 minus x times e to the x times ln of x, all divided by, that x is still on the denominator, times e to the x plus 1 squared. And that's a pretty good place to stop. There is our derivative of the original function, which was y equals ln of x over e to the x plus 1. Good example of using the quotient rule with logarithmic and exponential functions.